In this example, we've got a student who's investigating the relationship between width and area. And we're given that the equation of the model is, or the relationship is exponential. So again, if we were to plot a graph of W against A, we would know that the graph would have that exponential shape where it gets steeper as we move to the right. So what we do in order to estimate the values of an exponential model is we're going to take logs of both sides, and we always do that. So log A equals log of P times W to the Q. And we're going to simplify this right hand side, or split it into two different logs added together. So we're going to write that as log P plus log of W to the power of Q. And we've still got log A on the left hand side. And then we're going to use another log law, and we can bring the Q out to the front, and we can write that as Q log W So this gives us the relationship between log A and log W. So what we're going to do is we're going to use the graph that we've been given. Someone's plotted the graph for us that gives us the relationship between log A and log W, and then we're going to compare the two equations that we get. So from the graph, imagine we had, instead of log A, if we had Y on the vertical axis and we had X on the horizontal axis, then we know that we could write the equation of this line in the form y equals mx plus c. And m is the gradient and c is the vertical intercept. And we've been given that in this question. So we know that the equation of the straight line would be y equals 2x minus 0.1049. Well, we want to try and compare these two equations, but we can't compare them at the moment because it hasn't got A and W in it. So we're going to replace y with log A. So we actually know that log A equals 2 times by, now x is log W, minus 0.1049. So again, we've got two different ways of proceeding here. Method 1 would be to compare the two equations. And that's what you will have done in year 12 pure. So method 1, we're going to compare these two equations. We've got that equation there and that equation there. And you can see that they're basically in the same form. So we've got something times by log Q. Log Q is our variable here. Log W, sorry. And in this equation, it's Q times by log W. And in this equation, it's 2 times by log W. So if we compare the two equations, we know that Q must be equal to 2 in order for these two equations to be the same. And we've got our constant term, which isn't times by log W, which is log P. And here's our constant term in this equation. It's minus 0.1049. So we know that log P must be equal to minus 0.1049. So we can find out the value of P. Remember, it's log base 10 that we're using. So we can do the inverse of log base 10, which is 10 to the power of. So if we do 10 to the power of both sides, we get 10 to the power of 0.1049 on the right hand side. And the reason why we've done that is because the 10 to the power of and the log base 10 cancel each other out. So we get P equals 10 to the power of minus 0.1049, and we can work out what that is. That's 0.785 to 3 sig fig. So we found our values. Q is 2 and P is 0.785. Alternatively, method 2 just uses the equation that we got from the straight line graph. So if we take this equation, log base 10 of A equals 2 log base 10 of W minus 0.1049. Now we want an equation where A is on its own. We want to find out what A is. So we can do 10 to the power of both sides. So let's do 10 to the power of the left-hand side. And we can do 10 to the power of the right-hand side. And that whole expression is the power of 10. So on the left-hand side we get A, which is good because we wanted A on its own. And we're going to do a similar thing to what we did in the previous example. And we're going to use the fact that if we've got 10 to the power of C plus D, we can split that up into 10 to the power of C times by 10 to the power of D. So I'm going to split this up into 10 to the power of 2 log base 10 of W and times by 10 to the power of minus 0.1049. And this works because we would add these powers together if we were to combine it back into a single power of 10. So A equals, it's worth looking at what we're aiming for. The model gave it in this form, P W to the power of Q, P times W to the power of Q. So it's clear that this is going to be our P, this 10 to the power of minus 0.1049. So let's write that at the start, 10 to the power of minus 0.1049. And we're going to times that by, now we want it in that form, A equals P W to the power of Q. So what we can do here is we can simplify 10 to the power of 2 log base 10 of W. And we want to end up with W to the power of something. Well, the way that we can do that is we can, in the power, we can bring the 2 to the power of W. So, as a power of W, sorry. So we're going to have 10 to the power of log base 10 of W squared, if we do that. Now, log base 10 and 10 to the power of cancel each other out, so we just end up with W squared. So we're going to have times W squared. So it's clear that that is P and that is Q, because we've got it in that form. A equals PW to the power of Q. And then we could work out a numerical value of P like we did in method 1.